We're going to talk about password attacks right now as we switch over to taking a look at SSH. Once again, I'm going to skip over outdated service because we already covered this when we were talking about FTP, but let's take a closer look at insecure passwords. My target in this case is running an SSH server on port 22. Again, I can run that same nmap scan to learn more about this service. If I say nmap-p22-sv to get the version, sc to run the default scripts, and then my target. Running that, you can see that the state of the port is open, the assumed service is SSH, and the version is OpenSSH 9.2. I'm not going to bother going and looking up for outdated versions of the service because I know that this is the most up-to-date version of SSH. Instead, I'm going to try password attacks against SSH. So, when it comes to password attacks, what sorts of things can we do? Well, if we have a username and password combo, we could try that using SSH. If you remember from earlier, via anonymous access in FTP, we got that passwords .txt file, and that contained a password, a username and password combo. So if I cat passwords.txt, you'll notice it contains a user and ABC123, so I can try logging in with credentials user and ABC123. Let's say I didn't have credentials like that. What other sorts of password attacks could I try? Well, if I knew the default password, perhaps it's a company-wide policy that the default password is ABC123. I could try all sorts of different usernames with the password ABC123 and see what sorts of accounts I could get into. In the NCE Cyber Games competition, you'll be given some default passwords initially, which I believe are either going to be ABC123 or Change Me, and what an attacker could do is they could try that password against a bunch of different usernames to see if they can log in using SSH. There are multiple tools that are able to accomplish this. One is called Hydra, but the one that I find the easiest to use is crackmap.exec. Actually, in the future, crackmap.exec may be replaced with netexec, and there's some colorful history behind why crackmap.exec was actually discontinued, and a new fork is now emerging called netexec. But regardless, for now, I'll use crackmap.exec. I'll specify the protocol, so actually crackmap.exec can work with a lot of different protocols, not just SSH. But since I'm using SSH here, I'm going to say SSH. Then I specify the target, 10.0.0.11. And then, for example, to try an individual username and password, I can say -u for username. And my username in this case is user, -p for password, and in this case, the password I'm going to try is ABC123. If I run that, notice that I got this plus here for the username and password combo user and ABC123. This means that I was able to successfully SSH in with that username and password. If I were to, for example, try a different password, like I'll change ABC123 to ABC1234, this time it gives me back a minus, which indicates that I wasn't able to log in, and it gives me the message authentication failed. Instead of trying an individual username and password, which I could of course try manually, this is more useful when it comes to trying a list. So here, remember from before through SMTP, we were able to get a list of valid usernames. So if I print out this list, we know that root, MySQL, user, and FTP all exist on the target. So we can actually take that same password ABC123, and instead of trying it against one user, we can give it the name of a list, which in this case is usernames.txt. And this will try that same password against all usernames in the list. What crackmap.exec does by default is it stops when it finds a valid username and password combo. However, if I wanted to keep trying this password against other usernames as well, I can add -- continue on success. When I run this, you'll notice that for MySQL and for FTP, it didn't work, but the ABC123 password worked for both user and for root. So this means if I try to use that username and password and get in as root, I should be able to gain access. So if I do SSH root at in the target 10.0.0.11, and then I can say ABC123, you'll notice that I was successfully able to SSH into the target as root. I'm going to exit out of that. Another thing I want to point out is instead of trying the same password with a bunch of different usernames, which is known as password spraying, we could try what's called brute forcing. That's just the opposite. So I'm going to try a single username with a bunch of different passwords. Let's say I had this list of usernames here, right? And I know that user is a valid user. But let's say I don't know what user's password is. I can actually try a list of commonly used passwords and see if any of them are successful. To get a list of commonly used passwords, I'm actually going to use one that already comes with Kali Linux. If I go to user share wordlists and I print out the contents, you see rocku.txt. Rocku.txt contains a very, very large list of commonly used passwords. You'll notice that because this file by itself is so large, it's actually zipped to a gzip archive. So before we can actually use it, we have to unzip it. I can do that with gunzip, and then the name of the file, which in this case is rocku.txt.gzip. If I run that, of course, I have to run that with sudo because, again, I'm not the root user. And this may take some time to run because the file is rather large, but once it's unzipped, that zipped archive will no longer be there, and instead you'll see rocku.txt. So let's run that crackmap exec command again, but this time we're just going to try one username, and that's going to be user, and we'll try this password list, rocku.txt. We'll remove continue on success because we're just testing one username, so we know if we find the correct password for that user, we're not going to find any other correct username and password combinations. One thing you'll notice about this, now that it's testing out every single password, is it's actually pretty slow. And why is that? Because on a failure, SSH responds to you pretty slowly. So this is why, as an attacker, you might want to choose a different protocol when testing usernames and passwords. Despite this, you'll notice that as soon as it tested ABC123, it told us that user and ABC123 is a valid username and password combination. This is because ABC123 appeared in that list of passwords that we tried. In fact, I can grep for ABC123 in rocku, and I can see that there are actually a lot of different passwords that contain ABC123. If I wanted to search specifically for ABC123 alone, I can always use egrep, and I can do some regular expression magic to search exclusively for ABC123. I'm actually going to add this caret at the beginning. I'm going to add this dollars at the end. And that will search only for the string ABC123. And you'll notice that that does exist in our word list. Just like when we were analyzing log files, I can add -n to see where it appears in our word list, which will kind of give me a good indication of how long we as an attacker will have to wait before it actually tries that password. You'll notice it's the 10th password in the word list. As I mentioned before, SSH takes a little bit of time to respond, so we can actually try a different service rather than SSH that you can also log into. This is why I like crackmap exec so much, because it has a lot of different services that you can try built in, but the syntax for each of them is exactly the same. So I can leave everything else the same, but I can replace SSH with FTP, and this will try the same thing, but against FTP instead of SSH. By default, FTP is on port 21, so it's going to know to connect on port 21. When I tried to do this initially with the version of CrackMap exec that was installed on my Kali machine, I actually ran into a bunch of errors. However, these errors were fixed in newer versions. So I actually went ahead and I installed the newer fork of CrackMap exec called netexec. And the only thing I'm going to change is I'm just going to replace CrackMap exec with netexec. Netexec is pretty straightforward to install. If you look up netexec GitHub, you'll be taken to the GitHub repository, and you can simply follow the installation instructions on that GitHub repository to install netexec. It's very much a no-brainer, and you're just running the commands that they tell you to run. Anyway, when I try this with netexec, it gives us this nice error that tells us that the potential problem we're having is that there are some non-UTF-8 characters in our word list. CrackMap exec wasn't nice enough to inform us of this, but fortunately netexec is. And so I can just say ignore PW decoding as it suggests. And if I run this, now finally, we're going to perform that same attack that we did via SSH, but this time we're actually going to do it via FTP. So again, it's going to use FTP to try all those username and password combinations. As you may have noticed, this seems to be going just as slowly as SSH, unfortunately, but it's definitely worth, as an attacker, trying different services. And the big takeaway here is that any service that you can log into, you can try to brute force. In summary, we have kind of 3 different kinds of password attacks that we can use as an attacker. The first one is trying combinations of known usernames and passwords. This is known as credential stuffing. The second one is we can take a known password, try a bunch of different usernames. This is called password spraying. And the third one that I just showed is we can take a known username and try a bunch of different passwords. This is known as brute forcing. Switching to the defender's perspective, let's take a look at the traffic that was generated by that attack. I'm going to skip the actual Nmap scan and go straight to the traffic that was generated by the password brute force. If I take a look at this traffic here and I try to right-click, follow TCP stream like we normally do, you will notice that the first couple of exchanges are in clear text, but from there, the exchange switches to being encrypted. So we can't actually read the data that's being sent back and forth. That includes the login information. This is why SSH is a secure protocol, because anybody sitting in the middle and monitoring traffic can't actually read the exchange that's happening. The unfortunate side of this is that as defenders, it's harder for us to gain information about what the attacker actually did. So we can't really search by a username, and we can't really search by a password or a failed login attempt like we did before. If we actually want to make use of this traffic, one of the things that we can take a look at, if we follow that TCP stream again, is the attacker actually announced themselves. So when they connected to the SSH server, they announced themselves as Paramiko 3.4.0. And if you actually looked into what that was, that's the Python library for performing SSH connections. And that was the underlying library that tools like CrackMap exec and netexec used in this case. So if we wanted to search for evidence of an attacker, we could search for something like Paramiko. The problem with this is that the attacker could just use a different tool that maybe doesn't have that indicator. Right? For example, they could use Hydra. At the same time, maybe some legitimate user is actually using Python to SSH into our server. And in that case, Paramiko would also show up for that legitimate user. So this might work in a competition scenario, assuming that the attackers are using CrackMap exec, but it's not really a reliable method of detecting the attack. Another thing we can look at here is the FTP traffic that we generated when using FTP rather than SSH. If we're looking at the FTP traffic, I can right-click Follow TCP Stream. Because FTP is not encrypted in the same way that SSH is, all of the traffic that's sent back and forth is actually sent back and forth in clear text. That means we can read it. So we can actually see the attacker trying the username and password combo user and ABC123. So in summary, if the attacker uses a protocol that's unencrypted like FTP to test username and password combinations, we can see everything that they did as defenders. However, if they use a protocol that is encrypted like SSH, then as defenders, we're not going to be able to see those login attempts just by monitoring network traffic. One other option that we have looking at this traffic to see if maybe there is some evidence of a password attack is looking for login attempts. As a regular user that uses SSH, they're probably going to log in once and then run a bunch of commands. They're not going to log in multiple times in a row, especially not in a short period of time. So we can search for logins that occurred in a short period, multiple logins that occurred in a short period of time. And while that may be direct evidence of an attack, that could indicate to us that there is some sort of password attack going on. In order to search for that, I'm going to look at the actual key exchange. So the first thing that happens when an attacker or when anyone connects to SSH is this key exchange. And we can see this in Wireshark with this client key exchange in it. So if I say edit and find packet, I can actually search for client key exchange in it. This is not actually in the packet bytes themselves. This is not in the traffic that's being sent back and forth. This is in the info that's being presented to us by Wireshark. So instead of searching the packet bytes, we're going to search the packet list, and we're going to search for this client key exchange in it. And I can click find, and that will take us directly to all of the instances where that key exchange is happening. Then from there, we can take a look at the time that's listed, and we can see if those times are close to each other. But in order to see that, I'm actually going to change the time format a little bit so it's a bit easier for us to read. So I can go to Edit, Preferences, Columns, and where I see time, I'm actually going to change that. And I'm going to change that to give us the date as year, month, date, and time. So that's going to be a little bit easier to read than just that raw time that we normally get. If I click OK, now you'll see that the time is a little bit easier to read. We have the full date, and then we have the exact time. Now if I keep clicking find and look for those key exchange init messages, you'll notice this one happened at 37 seconds. This next one happened at 50 seconds, so that maybe isn't the best example, but all right, here we have 21:45:50. We have this key exchange in it. Now that a second one happened at the same exact time, at the same exact second. Now another one happened 8 seconds later. Here another one happened at the same time. Another one happened at the same time. And here one happened 2 seconds later, right? So we're seeing a lot of these key exchange init requests happening within a short period of time. So somebody is trying to log into our SSH server many times in a short time frame. From this information, you can probably guess that it is very likely an attacker performing a password attack. Where we'll really see evidence of this attack is looking at our log files. Now, the log files for SSH can be in a few different places depending on the distribution of Linux that you're using. If I go to the var log directory, in some distributions of Linux, you'll find this in the auth.log file here, or you might find it in the secure file here. So it could be in var log auth.log, or it could be in var log secure. However, in later distributions of Linux, like the Debian that I'm running right now, it's actually handled by journald instead. Journald works alongside systemd and logs events for specific services. The idea behind journal D is having one place to view logs rather than having to look at separate log files. I can actually view journal D logs with journal.ctl, similar to viewing systemd services with systemctl. So to view logs, I can simply say sudo to run this as root, and then journal.ctl or journal control. There's going to be a lot of logs to look at here, but I specifically want to look at logs for SSH. So I'm going to quit by pressing Q. And now I'm going to filter these logs to only view SSH logs. So I'll say -u SSH. However, again, there's a lot of SSH logs to look at. So I'm going to further refine my search. I'm going to press Q again. And this time, I'm going to look at logs that occurred in the past, 10 minutes. So in order to do that, I can add the --since flag, and then I can specify the exact minute that I want to look at logs from. Or in order to say the past 10 minutes, I can say -10 minutes. That's going to take the current time, it's going to subtract 10 minutes, and it's going to give us all the logs from 10 minutes ago. You'll notice that there are actually, because I ran this attack a while back, there are no logs from SSH logs from 10 minutes ago. But if I, for example, did 1 hour, so -1h, you'll notice here I have some logs for things that potentially occurred. And in these logs, you can see that there's some failed password attempts. So there's a failed password for user, and then it gives us the actual IP address of the attacker or of the client that tried to connect to our SSH server. And so a lot of failed password attempts in a row, like we see here, is a very good indication that an attacker is trying a password attack, because most of the password, username, and password combos failed, but only one is going to succeed. As you can see, they tried to log in as user multiple times, so this is good indication that in this case, it was a brute force attack where they're trying one username against multiple passwords. Another thing we can do, along with the since parameter, we can also use --until to further refine our time range. So if I wanted to see all the logs starting 1 hour ago until up to 10 minutes ago, I can say --until and then -10m. And that'll get us all the logs from 1 hour ago up until 10 minutes ago. Now you might be wondering, how do I actually search these logs for these failed login attempts? For example, whenever there's a failed login attempt, it displays the text failed password. So what if I, as a defender, just searched for the text failed password? There are a couple ways that I could go about doing this. The first way I could go about doing this is by piping the output into grep, as I'm sure you're familiar with doing. And then I can use grep to search for failed. And this gives us all of the failed password attempts, along with the exact time that that failed password attempt took place. You'll see that a lot of these failed password attempts took place very close to each other. So here, they're only 2 to 3 seconds apart. So that's a very good indication of a potential password attack. The other thing we can do is we can actually add a -n, just like we did before, to get the line number of that log. And so here we can see that that occurred at lines 112, 114, and 116. Now, if we view our logs again with journal.ctl normally, and I'm going to include all the same flags with it, just so that the lines are in the same place, right? I can actually jump to that specific line, so I can jump to line 114 or line 116 by using colon. So it's like if I say colon, and then I say 114, and then I press enter, that jumps me directly to line 114, where that failed password attempt took place. Alternatively, I could directly search for that string failed password while I have journald open. In order to do that, I can use slash. So if I say slash and then I search for the word failed, this will actually highlight all of the instances of failed password. And then as I'm going through this log, it's very easy to see where all the failed password attempts are. I'm going to press Q to quit. And now you know how to look through logs, both if they're regular log files in var log, and also if those logs are managed by journald. You might be wondering, where are these journald logs actually stored on disk? Well, they're stored in two places. So the first place is in run log journal. And if I list what's there, currently there's nothing there, but as those logs are being written, the first place that they get stored is in run log journal. Then for long-term storage, so that these logs persist across reboot, they're actually moved over to a different location, which is var log journal. So if I change directory to var log journal, and I list out here, you see we have this long named directory. And within here, we actually have two journal files, one for the system and one for the user. And within these two journal files are all of the logs that are displayed by journald. However, they're not written in a nice format where we could actually just print them out. You'll notice that if I try to print out that system journal, of course I have to do this with sudo, you'll notice that it's printed in this ugly format that journald knows how to read, but we can't just nicely print out. So I'm going to press Control-C to stop that. So how do we actually protect against these password attacks? Well, this is another example of attackers abusing an intended feature. All of these services that require login, the way they have to work fundamentally is they provide you access on a successful login, but they deny access on a failed login. Since that is fundamentally how the service works, there's not much we can do about that. But there are some other strategies we can take to potentially detect these password attacks and prevent them from happening. For example, we could enforce a lockout policy that if a user enters their password incorrectly too many times in a row, then they're forced to wait a certain period of time before they can enter their password again. This makes password attacks infeasible because the attacker can't just throw a ton of passwords. They can only check a few passwords at a time, and then they're forced to wait. Another thing that we could do is we could actually ban or filter a certain IP address if it tries too many incorrect logins. So for example, if an attacker tries the wrong password in SSH 3 times in a row, perhaps then that IP address, the attacker's IP address, will be banned and they won't be able to use it anymore to connect to our machine. There are actually tools, free tools, already out there on sites like GitHub that do this. One example of those is fail2ban for SSH. The problem with using these kinds of tools in cyber defense competitions like the NC Cyber Games is that the way these competitions are set up, oftentimes attackers will be attacking us from the same IP address as the scoring server is scoring us from. And the reason that it's set up that way is so that we as defenders can't just filter or create firewall rules that block specific IP addresses, known as IP filtering, because that would take away the fun of the competition. Besides, the attacker could always then just change their IP address to another one and run the attack again, which is just kind of an unnecessary hassle and doesn't really teach you anything. So on defense competitions like the NC Cyber Games, you're kind of stuck monitoring for these password attacks and ensuring that you're using secure passwords. Remember, if you're using a secure password, it doesn't matter if an attacker uses this password attack, they're never going to figure out the password that you're actually using if it isn't in one of those word lists. There are a couple other things we can do with SSH specifically to configure it more securely. And in order to do that, I'm actually going to edit SSH, the configuration file. So if I say sudo nano at c SSH, I believe it's just SSH, yes, and then SSHD underscore config. So you actually have SSH underscore config, and that's responsible for outgoing SSH connections, so the SSH client. But in this case, we're editing the configuration for incoming SSH connections, or the SSH server, and that configuration file is called SSHD config. Just wanted to make that quick distinction there. Anyway, once I'm editing that file, the first thing I'm going to do is I'm going to make it so root can't log in through SSH. Generally, you don't want attackers to be able to log in as root. The best practice in the Linux world is to log in as a normal user and then use sudo whenever you want to run things as root. So to prevent the root user from logging in through SSH, I have two options. One, I could simply comment out this permit root login. The other thing I could do is I could directly set it to no, and this would disallow root from logging in. Another thing you can do with SSH is rather than using password authentication, you can use SSH keys. If you were to use SSH keys instead, then I would take this password authentication option here, and I would simply change this from yes to no. However, depending on how you're being scored, this may or may not work. If you know that the scoring server is accessing your server through SSH by using a SSH key, then it's totally fine to turn off this password authentication or set this password authentication to no. However, if the scoring server is actually trying to SSH in with a username and password, you're forced to use password authentication, and in this case, you just have to leave this as yes, and you don't really have another option. The other thing you can do is actually also enable or disable public key authentication. So, once again, if you know that the scoring server is only checking a username and password, it's not actually using an SSH key, I can uncomment this pub key authentication option, and I can set it to no. This would only allow somebody to SSH in using a username and password and not using an SSH key. Once I've made these changes to my configuration file, I can always hit Control-O to save this, Control-X, and then just like with every other service, we're going to have to restart the service for these changes to take effect. So I'm going to say sudo system control restart SSH. And if I say system control status SSH, you'll see that the SSH service is now running. I'm not going to cover public key authentication more because that was already addressed in previous videos in the NCE Cyber Sandbox. Going back to that list of common attack vectors, we covered outdated service on SSH, we covered insecure passwords, so we fully covered SSH. Time to move on to the next protocol,